So the first proof, we have 7x equals 28. We're getting to x equals 4. What have I done to both sides of that equation to get from here to here? What happens?
Divide by 7.
I divided by both sides by 7, so I'm using division. So what thing on the pink sheet goes with division?
The division property.
Yes, or writing it out in words.
Equals divided by equals are equal.
Good. So anytime you divide, that's what you write. The second one, 4 is equal to 4. What property is that from the pink sheet?
Reflexive.
Good, reflexive property. And you do need to write the word property.
Well, we need to know this for the regions.
Oh yeah, definitely. There are some things where I would say I'm not sure if there will be a proof. You're going to have to do a proof. But you're going to be so good at it by then that we're going to do so many. The proof is going to be the part you're not afraid of. If x equals y, then x plus 8 equals y plus 8. What did I do to both sides? I added. And since I'm adding to both sides, my reason is equals added to equals are equal. The fourth one isn't actually on your pink sheet, but I bet we could get that property anyway. Distributive property. The fifth one, if A equals 4.75 and 4.75 equals B, then A equals B. Yes, transitive property works, for sure. Absolutely correct, not going to lose a point. What else works? Substitution. And the only reason I'm going to write substitution is because I like to stick to, if it's an equal sign, use substitution. If it's congruent, use transitive. However, transitive property is not wrong. Question 6. Again, not on the pink sheet, and we have to get kind of creative for this one. And there are actually a few things that you can write in proof. It's not about having the exact words as the justification, it's just that you have to justify it to me. So I have, and I know that this isn't true, 2 plus 7 does not equal 12 plus 4. But my conclusion does kind of follow it. 9 equals 16, because I turned this into a 9, turned this into a 16. What might defend those changes?
Commutative property.
Good guess, but not commutative. Commutative is the property that says like 5 plus 7 equals 7 plus 5. Got another guess?
Additive property.
We didn't add the same thing to both sides. What did I do?
You combine like terms.
Yeah, so she writes combining like terms. Does that justify it? Or does that explain it? Sure, combining like terms is great. There's an S word that works.
Symmetric?
Not symmetric, good guess. Matt?
Simplify.
Simplify. If he says simplification, does that work? Did I simplify both sides? Yeah, I'm going to go with simplification. If he writes simplify, we're good with that too, but combining like terms, simplification, and actually I would even take substitution, because did I substitute a quantity for an equivalent quantity?
Yeah.
And that's what substitution means. So that would also work in that box. And then the last one, if x equals y, then 8x has to equal 8y. What do we have happening?
Equals multiplied by equals are equals.
Good. That one, the equals sentence, I feel like is one that's really confusing in the beginning when we're going through the properties, but then it will probably end up being one of the easiest ones to spot when we're actually doing a proof. This is just practice mini statements. Full proof. This is what a proof is going to look like. You are going to be given a couple of things. In this case, I'm given 2 facts. And then you have to prove something. So your goal in a proof is to show that these facts can lead you here. And to get from here to here, you have to go step by step, and you have to explain, using the stuff from your pink sheets, why every step works. There are 2 styles of proof that we do in this class, a 2-column proof. This is the probably more popular way. A lot of books will only do 2-column proofs. If you talk to your parents, they probably only remember 2-column proofs. Some teachers actually only teach 2-column proofs. But the idea behind this is you give a statement, and then over here, you have to give its corresponding reason. And our proof is actually going to have 5 steps. And part of your homework for tonight is going to be to complete those 5 steps, but with the video, not on your own. But that's what a 2-column proof is going to look like. The second way to organize the proof is a flowchart proof. Our proof has 5 steps, so this is still going to have 5 steps. The only difference between a 2-column proof and a flowchart proof is how you organize it on the page. It's the same exact words. Everything is identical. It's literally how you organize it on the paper is the only difference. So in a flowchart proof, it's going to look something like this. The statement goes inside the box, and then outside of the box, you're going to have a reason. And then sometimes when 2 boxes work together to lead us to a conclusion, we actually draw that in the picture. So like these 2 boxes lead me to this conclusion. And then maybe we pull in another fact from the outside. And then these 2 boxes work together to lead me to another conclusion. So the arrows, they're really illustrating what pieces are working together. Notice 5 boxes. The previous question had 5 steps. Everything is going to be exactly the same. Paragraph proof is where you explain all of it using sentences. You are allowed to do paragraph proofs, but I don't think any of you are going to choose that method. It's tough to keep it organized and not leave out details. These are like linear, everything's in your face, it's short and to the point, and it is tougher to skip steps. So tonight for homework, you're going to have another video. You're filling in those boxes.